Hey, hi guys, welcome back to Tech Engineer. நான் உங்கள் Shiva. Today we are going to discuss about why the capacitor bank is very important in power system. So in the power system, we have a several reason we are using. The first one, power factors improvement, and second one, voltage stabilization, and number three, reducing electricity cost, and number 4, increasing system capacity, and number 5, reducing line losses, and one more thing, supporting to renewable energy system, and seventh one, protection of equipments. So let's see one by one. So first point, power factors improvement, right? Power factors improvement. What is power factors? The power factors measure how efficiently electrical power system used, right? So for example, so we have a 1000 watts power supply. So now we are utilizing only 800 watts. Now the 200 watts is considered as a losses, right? So it is impact, right? So actually power factors have a different types. One is leading power factors, another one is lagging power factors, another one is unity power factors. For unity power factors is 100% of efficiency of the system, and leading lagging its impact to the efficiency, right? So here a low power factors indicate insufficient use of power. So this is for example 0 to 1 we are considering power factor value. Now it is 0.4 means it is impact to the power, right? So what is the power formula? Power equal to V into I cos pi. So this phase angle difference impact to the voltage and current. So that's why the power was impact, right? So here what is the function of capacitor span? So it is improve the power factors by supplying reactive power kVAR power to the system, reducing the reactive power travel from the grid. These reduce electricity cost and increase efficiency. For example, in the transmission line it's coming to 0.7 power factors. Now we are connected capacitor span here. So now it is improved 0.9 volt, sorry 9 power factors. So this is the major concern, the capacitor span why we are using, right? So next one, voltage stabilization. The capacitor span help maintain a stable voltage level by providing reactive power support. Here 11 kV coming, and now it is 10 kV only available, means step down transformer here. So now we are connected to the capacitors, it is improve the voltage, right? So these ensure smooth operations of equipments, prevent voltage drop. So that's why we are choosing capacitor bank. So third one, reducing electricity cost. How it is reduce the cost? In power we are using the power from the TNEB, right? Tamil Nadu Electricity Board here. So it is indicated when you are using only poor power factor means it's come to penalty, so that these capacitors bank reduce the penalty. That's why the cost is reduced, right? So fourth one, increasing system capacity. How to increase the system capacity? Supplying reactive power locally, the capacitor bank reduce the burden on transmission line. So when you are connected in the capacitors here, it's reducing the transmission line burden. So this is allow the system carry more active real power without upgrading any infrastructure changes. Okay. So fifth one, reducing line losses. So whenever the power coming here to here, 11 volt 11 kV, sorry, 11 kV. Here it's coming to 10 kV because of the transmission line voltage drop, right? So that's why reactive power flow increase losses in the transmission line by providing local reactive power. The capacitor's bank reduce these losses. So whenever we connected in the capacitor's bank here, it is reduce the losses in the transmission line and improving overall system efficiency, right? So another one is supporting renewable energy system. It's like wind or solar. The capacitor bank help manage reactive power fluctuation, ensuring grid stability. So actually here is wind turbine is there, so it's power come to the transformer and it's come to the your load, right? So it's maybe have some fluctuation. Now we connected in the capacitor bank here, so now it is output, it's control the fluctuations, right? So one more point, protection of equipments. How to protect the equipments? The stable voltage level reduce stress on the motors, transformer and other electrical equipment. That's why the lifespan has been increased. So that the capacitor's bank is very important. So what are the applications for the capacitor's bank? Industrial plant with heavy machineries, the large commercial building with high reactive power demand, and power distribution and transmission system, and a renewable energy form. So here how to calculate how much of power factors. So here I display the formula fundamental. The concept power factor is shortcut PF is the ratio of real power and apparent power. The real power indicated in the B and apparent power indicated in S. The power factor formula is B divided by S equal to cos pi. Where is the cos pi? Pi is the phase angle between voltage and current. Earlier I discussed, right? Right. So in role of capacitor's bank and leading power factors QC, common state for lagging reactive power in the load. For example, here real power 100 kilowatt and the initial power factor is 0.8 lagging power factor here. The apparent power divided by power factors. So here is the 100 I put it here and 0.8 it here. So now with the apparent power kVA 125, right? So the required reactive power, how much of reactive power we want? So root of apparent power square minus and a real power square. Here is the apparent power 125 and the real power is 100. Now 75 kVAr capacitor's bank is required for this 100 kilowatt system, right? So now we are connected 75 kVAr in the power grid. The 0.8 is now now it is increased 0.95 power factors, right? So another one is voltage stabilization. The concept capacitor's bank improve the voltage by reducing reactive power demand as per Ohm's law. What is Ohm's law? Here voltage I into R, wherever I is indicated as current, R is a resistance and V is the voltage, right? So without capacitor's bank, a motor may experience 10% of voltage drop due to reactive power. Adding a capacitor's bank supply 80% of the reactive requirement reduce the drop from 2 to 3%. Okay, so it is major point in the power system. So another one, reducing electricity cost. So earlier we discussed theoretically, so now we are going to see the example. Monthly load 500 kilowatt and the power factor is 0.7. The apparent power 714 kVA. After adding capacitor's bank to improve our target 0.95, so what is our requirement? 526 kVA it's required in the power system. It is reducing the penalty and power consumption, right? So one more point, increasing system capacity. How to increase the system capacity? So here apparent power, right, B square plus Q square. For example, transformer rated for 1 MVA with 600 kVA or reactive power only 1 and 0.6 square in 0.8 megawatt for the real power. Adding 400 kVA capacitor bank reduce reactive power to 200 kVA, increasing real power. It's come to how much? 0.8 megawatt. So this is increase the system capacity, right? So one more point, reducing line losses. How it is reduce the losses? The power loss equal to I squared R, right? Initial load current 50 amps, for example, with the power factor of 0.6. So now we submitted the value in the formula I divided by power factor's improvement. How much of power factor we need to improvement, right? So here I is 50 amps and 0.9 is our requirement. Here is 0.6 only, so that's why we are putting here. Finally we got 33.33 amps, right? So now we are going to apply here 33.33 divided by 50 square, it's come to 0.4 power loss load. Now losses reduce 56 percentage, right? So now for finally we find the capacitor's bank formula, how to calculate the capacitor's value. C equal to Q divided by 2 pi F V squared. So where is the reactive power in the kVAR Q and frequency F, and V is the line voltage in the system, right? For example, Q is 50 kVAR, the frequency is 50 Hertz, the voltage is 400 volt. Now we are going to submit this formula. So now we are getting 4.97 microfarad, right? So now we are coming to the summary. The capacitors bank are essential for saving electricity cost and improving system efficiency and capacity, and maintaining the voltage stability, reducing losses. For example, added in the earlier subject, right, the voltage stabilization 10 to 20 percentage is come to down. Okay, so thanks for watching Tech Engineer. Now we are understanding the capacitors bank and how it is important in the power system, and how to reduce the power factors, how to select the capacitors bank. So a lot of things we are discussing in this video. So we will discuss another video, another topic. Bye.